In Lesson 3, we talked about physical properties of matter. And we said that physical properties are any characteristics of matter that you can observe or measure without changing the identity of the substance, without changing that substance into a different substance. And we're going to do a little demonstration today, and this is an activity that you can do at home. The only materials you'll need for this activity are just a plastic Ziploc bag, any size will work for this, some wooden kebab skewers, and then you'll just need a little bit of water to go in the bag. Now we're going to be looking at two physical properties today with this activity. Those properties are elasticity and flexibility, which are very similar, but there is a slight difference. Flexibility describes how well something can bend or flex. So if we look at this plastic bag, we can bend it very easily. It's very flexible. If we took a pane of glass and tried to bend it, it would obviously shatter in half because glass is not nearly as flexible as the plastic in that bag. The second property, though, that we're going to be looking at is what's called elasticity, and that's the ability of something to stretch and kind of go back to its original position. A balloon's a good example of something that has a lot of elasticity. If we inflate the balloon, it fills up with air, it stretches a lot, and if we let the air out of the balloon, it shrinks back almost to its original size. So we're going to be looking at those two physical properties through a little experiment that we do with our Ziploc bag. Now our Ziploc bag that we have here is made out of plastic, and this plastic that makes up this bag is a type of what's called a polymer. And if we know our prefixes, suffixes, we know that the prefix poly means many, and basically what a polymer is it's a long chain of molecules that's connected together, kind of like beads on a string. And there's lots of different types of polymers, but plastics are a big category of polymers, and that's what we're going to be looking at today. Now the first thing we need to do for this experiment is take our plastic Ziploc bag, and we're going to fill it about 2/3 of the way full of water. And I've got a bag here that's already filled up and ready to go, so once we get our water in our bag, it's going to look something like this. Again, about 2/3 full of water, don't fill it all the way to the top. And then we just want to kind of hold our bag out here, and we're going to take our wooden skewers and we're going to stab them into the bag. And it's important too, you notice if I just kind of poke at the bag a little bit, they don't just punch right through. So we've got to punch it pretty hard, just make sure your fingers are out of the way so you don't stab your hand. But we're going to stab our wooden skewers into the bag, and we're just going to watch what happens due to the flexibility and the elasticity of this polymer plastic that makes up the bag. So we're going to stab our first skewer in. Here we go in 3, 2, 1. And we just poked a hole in the bag right here below the water level. But something that you notice, even though there's a hole in the bag, the water's not leaking out of the bag. And the reason for that, again, it's because of the elasticity and the flexibility of this polymer material. Because as that wooden skewer goes through, it almost is able to kind of form a seal as the plastic stretches with the wooden skewer, as it kind of flexes back and rebounds back to fill in the space around the wooden skewer and the bag. Also, you know, with the water tension of the bag kind of pushing on it, it keeps any water from coming out. We may see a little drip here and there, but it's definitely not flowing out like we would expect it to if we just poke a hole in a Ziploc bag. We're going to take another one here, and we're just going to do the same thing. We're going to stick it through the bag, and we're going to watch the elasticity of the polymer as it heals up around the bag to close off the hole. And you can see if we just keep taking these wooden skewers, and if you try this at home, if you have about 10 of these that you can use, the challenge is to see how many of these skewers can you stick in the bag without the water flowing out. And you can see, here goes our third one. And if we just keep sticking them in, you know, different heights, different angles, you just want to make sure that they do go in below the water line. And like I say, you may see a drop of water here and there coming out, but it's definitely not going to be nearly as much as you would expect from having now 1, 2, 3, 4, 5 holes in our bag. And we're going to go ahead and put 5 more in here. Get 10 skewers in the bag. Go in from some different angles, different heights, like I say. Whoops. So now we have all of these skewers in the bag, and there are a few drops of water, like I say, leaking. But because of the flexibility and because of the elasticity of this polymer plastic material, we're actually able to still have this here without making too big of a mess. Now, I would recommend when you try this at home, you probably want to do it over a sink or outside just in case. And especially because when we go to pull these skewers out, it's really going to start leaking out, because now if I pull the skewer out, we've got a big hole in the bag, so now the water is able to leak out. But as long as the skewers are in there, the flexibility of that polymer material is able to hold the water in the bag, which is a pretty cool little science demonstration. We call it the magic bag. It's really not magic, it's really just polymer science, flexibility, and elasticity. But it's still a really neat science experiment that you can show to your family and friends. So I hope you've enjoyed this experiment today. I hope you've enjoyed learning a little bit about polymers, about flexibility and elasticity. And just remember, these are a couple of our physical properties of matter. Properties we can observe without chemical reactions, without forming new substances. Over the next couple videos, we'll look at some more physical properties, and then we'll get into the chemical properties of matter.